Hi there, I'm Hao, and this is just another video of me solving random linear problems. So let's begin. You're given an n by n binary matrix grid. An island is a group of one, right, representing the land, like the example here, right, island. And it is connected like four directionally, like horizontal and vertical, which means you cannot go diagonally. You may assume that all four edges of the grid surrounded by water, right? So the outer bound will be just water, the ocean. Okay. The area of an island is the number of cells with a value of one in the island. Okay. So this one, with this island, we have the area of four, right? This island, we have the area of six, right? So on and so forth. And what do we want to do? We want to return the maximum area of an island in the grid. And if there's no island, return zero, right? So it is pretty straightforward, right? We can just iterating to each node, and anytime when we find a island, right? We just completely exploring it by running the DFS, the depth first search audit, right? So if we found a one here, we keep exploring the neighbor, right? If it is the water, we stop. If it is a bar, we stop. But if it is an island, we keep going, right? Four way, right? Four way, right? Four way, right? And if we're looking at this node, right? We will potentially using the node we already visited, right? Which means we need a set to keep track of the visited node, right? Um, but to save some space, we can just set the visited node to zero, right? So you found an island here, right? In here, let's say you found an island here, here, right? So you count one, right? And you set it to zero, right? You look at in four ways, you reach the water, so you stop, right? And you re return. Here you found an island here, right? Um, you set it to zero, right? Set it to one, and then you look at the neighbors, right? So this is zero, you stop. This is outbound, you stop. So you look at the one here, right? And you keep exploring one plus, right? You increase one every time you found a one, right? Here and here, right? So four. So you return one, return one, return one, right? And return one up here, right? So the total would be four, right? And all the node here will become zero. So you just repeat the process over and over again. And and we will just iterate into each node one time. So the time maximum will be O m by n, which is the size of the grid, the matrix. And the space would be constant, I guess. We just need like a max variable to keep track of the largest island, right? The largest like area. So let's go ahead and code this up. We can do this using an iterative approach using a stack too. But I just like the recursion version of it because it makes my code look a little bit cleaner. So let's code this up. Create a few variable here equal to grid store not long. And so for equal to zero. And then column, right? So we want to um, iterate through each node, right? And run the DFS on each node if we found an island, right? So if we found an island, the grid of row and then column is equal to one, right? And we want to run the DFS on it, on the row and the column, right? So we can so the return value from the DFS will be the maximum, will be the area, right, of the current uh current area, right? So and then we just we just update our max area. So if current area is greater than the max area, then the max area is equal to the current area, right? And we will just like return the max area at the bottom, right? And the max area can initially be set to 0, right? So we will return 0 if there's no island, remember? So we have our DFS here, with the row column, right? Okay. So as we exploring, when do we stop? We stop when we are outbound, right? So when row is set at 0 or column is set to 0, row is greater than equal to rows, the column is greater than equal to columns, right? So when we outbound, we stop, or when we reach the water, we stop, right? So brick row and column is not equal to a land, right? We want to return 0 after yeah, we want to return 0, right? Otherwise, we want to set the visited node, right? Row column to 0. We just set it to the water. So now we're not gonna get into an infinite loop, right? Yeah, and then we're just gonna return the area recursively. So DFS of row minus 1 column, DFS of row plus 1 column, plus the DFS of row column minus 1, plus the DFS of row column plus 1, right? So the one here is for the current node, right? And we add the area, you know, like the combining area on the left side, the right side, the top, and the bottom, right? If we found like, let's say we found a a, a node in the bottom, we will return 1, right, eventually. So we just add 1 to that. But if we reach the water, we will just return 0, and we just add 0, right, to the result. And then the return result, the return value of this function will be the current area, right? And we just compare and update our max area. Okay, so let's try that. Ah, this is a let, right? Because we want to be able to update our max area. Okay, accept it, submit, and it worked. We are doing very well with the space here. Thank you for watching.